I've drafted some questions for Barry, and we were thinking, to keep things pretty conversational and kind of walk through some things around trends in publishing and other pieces. Barry and I work together pretty often, and we have a maximally casual and relaxed relationship, I think. So we invite you to join us in our maximally chill relationship. So we're going to cover some of these topics today, a little bit of an introduction. We're going to talk about publishing, a little bit about research data, open science, less open science, and the hustle. So we'll get right to it. Barry, I don't suppose you tell us a little about where you're from, where you've been, and how you ended up in the chemistry department at UNB.
Sure. I've had a rather meandering career. I started at Mount A, did some undergraduate chemistry there, relatively local to UNB. Do we call Mount A the enemy? No.
No.
Colleagues, right?
Did you write for the Argosy?
No. And then I did a PhD at Western in the chemistry department there, and then was offered a couple of subsequent fellowships, one at the University of Edinburgh in Scotland, which was pretty cool, and then another nice fellowship at Queen's University in Kingston, Ontario. At that time, there were no jobs in Canada. So I applied back for faculty positions back in the UK because we were familiar with it, and from a visa perspective, we were pretty. It was pretty easy for us to move back and forth that way. So I was offered a position there at the University of Kent in Southern England, and then there was an opening at UNB. My family's from Moncton, and I thought, this is an opportunity to move back to my home province, and there's not a lot of scientists, a lot of professorial scientists that get an opportunity to move back to their home province. So I thought I would make that happen. So I did. Here we are.
Awesome.
Yeah.
Yeah, it's actually very similar. I ended up as a librarian here, lucky enough to be in a place that I am from, and getting into a position here, but that is
rare,
not
yeah.
is not common.
Yeah.
Been many times to France because Kent is in the border.
Oh, we go all the time. Yeah. It's brilliant. Yeah, it was great.
Why chemistry?
So actually started off wanting to be a doctor, medical doctor.
Marine biologist?
My grades were terrible, and decided, well, there was an opportunity to volunteer in a research lab.
Right.
And by the end of my second year, I went in and did some chemistry, like applied chemistry, which is, people don't really know what that means, but you get to go in the lab and like do stuff that might impact society in a positive way. And so getting the opportunity to be creative, not like an fine arts person, but creative in a scientific way, but working with matter rather than materials, was really cool. And it inspired me, and was able to, that was sort of like, everyone has their moment where it just kind of clicks. That was my moment. And from there, I was kind of chased it after that. Yeah.
Awesome.
Yeah.
You and I have talked about some of the few interesting things you've worked on sort of in the material space before, although sometimes I feel like those conversations happen under what should be a cone of silence. But would you mind talking a little bit about some of the cooler projects you work on, just to give people a sense of some of the stuff you've done?
Sure, yeah. So when we were living abroad, my first professorship abroad, we developed a really cool innovation that helped the defense labs in the UK destroy en masse chemical warfare agents, which was a really cool project. We developed a sponge with a catalyst that swelled VX nerve agent, which is actually more like an olive oil type of consistency. It's not a gas, like it isn't like they say in the movies. Right. And yeah, we were to swell drums of it and destroy it to help the world. And that was a really cool project, and they've actually made several hundreds of kilos of it and are deploying it abroad to all of their different sites for that. Beyond that, since moving back to Canada, we do a lot of work with luminescent materials, so things that glow in the dark, basically. Also the same kind of things that are in your mobile phone, so organic LEDs. So we develop a lot of materials for that. The ones we are working on also happen to be anti-cancer to some degree. So we're chasing that on the side. I am not a cancer expert. We farm that off to my collaborators. We make them, our collaborators test them. And then we're also now doing a lot of work trying to disrupt industry in a good way. We're working with some mining companies in terms of looking at how we might be able to decarbonize some of their processes, and also sort of in parallel generate some carbon capture materials that we can use to harvest the CO2 and then make use of that CO2 in other ways, like in polymers and other things. So yeah, trying to save the world, basically.
Yeah.
Yeah.
Right.
That's the overarching scheme.
Yeah, sure. And it's a normal and easy thing to do.
Sure.
And anyone should do it. But I think it's a useful conversation because a lot of the time, and you probably get this, like when you're talking to somebody who works in science, like I know because I did a history degree. I just imagine someone whose job is formulas and really for no actual purpose. And so it's cool to hear like these are concrete results of the work that your lab does,
Yeah.
the work that your grad students are doing, and the work you're publishing about and all of those other pieces.
Yep, exactly. And like I always hang my hat on it. The most important part of what we do is train young people to then go do their thing. And without them, I would have no research program, and without me, they would not find their path. And so it kind of works both ways. And I try to give them opportunities that allows them to see other ways to go. I always say to my colleagues, and we all agree, each student that comes into our labs, are going to leave our lab at whatever time they think they need to leave. And so, we literally train people so they can leave. And a lot of people have a hard time with that because they're trained people and they're leaving. We need them to do the work, but that's the conflict of interest that we have to kind of navigate.
Yeah.
So
Awesome.
Yeah.
Okay, we'll move on. Toe to tit is a label you didn't like.
No.
Could you walk us through the life cycle of a research project? So from conception to grants through to publication. You and I have talked before about, how you'll, bump into Dave McGee somewhere and have a conversation, and then he encourages you to apply for a grant or some other work.
Yeah.
I don't know if you could elaborate a little bit on that process.
Sure. So in our roles, there are always opportunities to apply for funding, and there's national funding, there's provincial funding, there's university funding, institutional funding, but you need to have something to apply with. You need to have an idea, something exciting, something that you think people will latch onto and think that's a good idea. And so really it comes down to being inspired. So you need inspiration, right? You'll see something in a research article or something in the news and you think, oh, I bet you we can do something like that, but maybe a bit better, or it's a completely out of left field thing that you decide to develop. So yeah, you need that inspiration. Then you need to design whatever it is you're going to want to do. And then we've got to write the proposal and hope that people believe what you're telling them. I joke about how basically my job is to write science fiction because I write research grant after research grant. None of the work's ever been done before. It's never been done before. It's literally science fiction, and we hope to make it fact, basically, by getting the money and then going in the lab and trying it out. So yeah, that's kind of how we look at it. So we apply for the grant, then we have to hire the students or the researchers to come in and do the work. Then we have to do the work in the lab, mix the chemicals, make the materials, characterize them, show that they do what we want them to do.
Right.
And if they do, we write it up. And what that means is, and it depends on, we're going to talk a little bit about that today, but what that means is that there's an opportunity for either open science or IP protection, so filing patents and things like that, and that's important. But what people don't understand is that you can actually have open science after you've patented it. So this is something that we'll discuss in a bit. But once if you're going to protect the IP, once the IP is protected, you can then publish the work, write a nice research article, make it public, share press releases about it. We've done that, and then hopefully you get lots of traction and lots of interest in the science that you're doing.
Yeah.
Yeah, so that's kind of how it works. And I mean, there's various degrees of success, and and places where you might send the work and things like that. But yeah.
Yeah, and we'll talk about that too in a second, like picking where your work goes.
Yeah, because that can be challenging.
Yeah, definitely. But like, what? So you've painted a picture of you writing science fiction, which I picture is basically like throwing spaghetti at the wall. So you've got a lab with some students, you're seeing what could be plausible, and then you write a grant based on like something you've got a bit of a foothold on, or do you come up with the idea first, or is it a bit of a blend?
Yeah, I think it depends. So sometimes it's something that we know it's doable.
Right.
And then maybe you want to elaborate on it. Sometimes we'll hire a student for a short amount of time to kind of just do some test reactions just to get a lay of the land, see if we can make the science really make it work. And if we get some semblance of success early, then we'll write a grant to like fund a bigger project and hopefully make that a reality.
Right.
And then sometimes it's follow-on funding. You've established something and you want to make it bigger.
Right.
Right, and then that's a bigger thing that you'll apply for. But yeah.
Yeah. Are there benefits to having work that isn't like grant funded? Like, do you ever find a situation where you're like, it's good that we don't have to report on this because we're just doing something to figure out if it'll even work, and there's no, or do you always, is it like always beneficial?
No, the reality is there's always little sneaky little things that we're trying out,
Right.
even with some of the funding that's funded for something else. We have in Canada what's called the Discovery Grant Program. And though in the Discovery Grant Program we may be proposing to do some weird and wonderful things, it also, within the framework of that, allows us to try other weird and crazy science. And that's where we can really kind of like pinpoint what arrows we want to chase at a really early phase without having to worry about reporting on if it may not be linked to whatever that project was meant to be.
Right.
Actually, it's a beautiful program that Canada has. It's one of the only programs like that in the world where we can do that. Yeah, it's
Awesome.
great. Yeah, it's fantastic.
And I guess it just sort of related, what's your relationship like with the research office in this space?
So the research office is actually really important, and they play a number of roles. So we have pre-grant people who review our grants, make sure that when within our writing, they will edit our language, which is helpful because sometimes we want our grants to be pitched at a specific level so that either it's more lay or more scientific, and it really depends. But they'll also make sure that what we are writing hits on the criteria that the grant requests. And sometimes when you're deep into it, you miss that, right? That small detail. It sounds like it's a big detail, but it happens. But then we also have people who are out in the economic realm chasing partnerships for us and looking to help us establish collaborations with industry. They lobby for us with government, for different government agencies for funding. Our research office have a really close relationship with funders like Research MB and MBIF, and it's sort of really, they do really valuable work for us. And I mean, they're kind of like the unsung heroes. People don't really hear exactly what they do,
right?
But they do lots of secret stuff behind the scenes that no one really gets to see, and it's super vital actually. Yeah, and they're super helpful.
Actually, kind of an interesting follow-up. So normally when I talk to people about funding, they're chasing like federal grants.
Yeah.
What is the likelihood of chasing like what's provincial money like, and how often do you chase it?
So there's an annual cycle with the provincial funding, and there's usually, it depends on where you're applying because the flavors of money vary.
Right.
So in science, there's innovation funding, which people would say that there's not that much, but there's quite a lot actually if you know where to look,
right.
And know how to pitch your work. In the arts, it's a little bit different. So it's more federal.
Right.
There are some like social development funds that you can apply for through Research NB, and now that Research NB is no longer NBIF and Health Research, NBHR Health Research Foundation,
right.
It's opened up a lot more sort of flexibility for what they can fund,
right.
Which is bad for science, but good for everybody.
Right.
But I think the question is about provincial funding?
Yeah, just like the...
So there's an annual cycle, but also there's actually, as I said, there's more than what people think.
Right.
Actually been funded very, very well by the New Brunswick government. And whenever I speak with the funders, that's the other thing. Because we're in New Brunswick, we can just like email them and they'll write us back. We don't have to go through like a giant portal of like army of people to talk to people who know what they're talking about within the frameworks of the program. So it's actually really helpful and really good to be in New Brunswick in that way because they're just people that they literally work up the street, which is actually really nice.
Right, but when you talk to the tri-agency, it's like talking to a black box.
Yeah.
And you're always surprised when you meet somebody who works there and you're like, what, there's people?
If you're at Windsor and you want to talk about the Ontario Innovation Fund, it's someone in Ottawa, and like, it's not, you can't do that. So, yeah, it's great.
So we will move on from here. So open science.
The meat.
Yeah. When you're sharing your work, how do you decide what you do or do not want to make open access?
So open access is something that I've been navigating for a while because when I was in the UK, which was, I guess it was like 2012, they started to launch this stuff there. So they're a little bit ahead of us here. And it's tricky. There's elements of it, well, I guess I could say it's philosophical. It's kind of how you want to navigate your science and How visible do you want your science? And what are the reasons why you want it to be visible, right? Like that's important. So for me, I want my science to be visible for a few reasons. One, it means that the work may have more impact later on. So I write up a project, we publish it, and then someone comes along and says, oh, that's really cool. And they build on that, and that's how we push science, right? And then it's just like a breadcrumb trail of development and innovation along the way. If that is behind a paywall, there is a huge portion of the world that don't have access to that science because they have to pay for a subscription or have to pay for the article. The article's expensive. And if you don't have access, then nobody sees it. And so being able to publish open access means that not only do scientists get to see the work, but the media can openly see the work. They can push that innovation globally, and then people can take that and do great things with it. So it's not just about what we can develop,
Right.
but it's what other people can develop from what we've developed, and it kind of snowballs from there.
Right.
There's different ways to do open access. So in addition to the open access journals, there's gold and green and a number of other, and what those mean are basically different levels of access. Gold
I can
means-
explain it.
Yeah, well, why don't you explain it?
Yeah, sure.
Yeah.
Yeah, so gold open access is when you pay to publish in the journals. The journal's open access, but everybody who publishes in it has to pay a fee to do so. Green open access is usually referred to also as like self-archiving, where you can save some version of that work and share it elsewhere, like in an institutional repository or on archive.org or some other location. So it's like a version that you don't have to pay to make open access that is somehow less than the final published version, but still the work in someone's hands.
They also can be open access after 12 months.
Yes.
Those ones, right?
Yeah.
So, yeah.
And then there's like a hybrid model. So that's like a traditionally published journal that has subscriptions. But if you pay a fee, then you can get an open access version. And then there's like the sort of platonic ideal of Diamond OA, which is just free from toe to tip. People don't pay to publish. All of the funding for the operation of the journal comes from like grants or other forms of monetization that don't require authors to pay for that work. And then like there's some other little models in between, just to make things super straightforward and easy for people to understand. I think, there's a lot of options. It's a lot to navigate.
It is, but I mean, if you have a fairly open philosophy about it, then it's not that hard. You just pick the ones that you think is the right place to go. And we'll talk about that actually later. But what do you or do not want to make open access? And that really comes down to whether or not, sometimes it's whether you can pay the open access fee, right? That's a challenge if you want a gold open access. And then also whether or not the work's going to be proprietary.
Right.
So if you want to patent something, you'd have to wait till the patent is filed, or at least the provisional is filed. Different jurisdictions have different requirements. Once that all ticks over, then you can publish it however you want.
Right.
It just means that anybody who wants to make use of that innovation would then have to pay licensing fees because of the patent. But that's a whole other can of worms.
Yeah.
But the science itself, once it's out there, would be fully open and visible.
Yeah.
It's kind of complicated.
Let's say I write open source software and I license it with like a new public license or an MIT license. When the licenses are hard to enforce, if you're a small organization or a person and someone takes your open source code and strips the license out and puts a copyright on it and they say it's theirs, that's against the laws of the license, the rules of the license. But litigating is almost impossible. Like you don't have a lot, like all you can do is kind of shake your fist at this person who did this thing in bad faith. And you have to do a lot of due diligence to prove that they took it. If they changed the code, they could maybe make an argument that they didn't take it. And then, you have to find someone who's going to handle a lawsuit between someone who's living in, Korea or someone who's living in France or someone who's living in the US. And then once you have like international patent and copyright law, it gets really, really expensive and complicated to do. So you kind of have to rely on this idea. And I know it sucks. Like there are bad faith actors always, right? Your mitigation is like, look, we'll put a copyright license on this. And if people aren't ghouls, they'll cite it. But like the reality is some people are ghouls And you do your best to keep the ghouls out and make sure that your work is going in places where it ought to go. There's an organization called COPE. It's the, what is it? Something Community Organization Publication Ethics, I think. Committee on Publication Ethics, something like that.
Probably.
Yeah, and their entire thing sort of built around this narrative of academic integrity, which is like the hot conversation in publishing, right? Because there's AI implications and there's all of these other implications for academic integrity and what it means for someone to have it and to be able to associate a level of integrity with any given work. Is that, let's say I'm using AI, I disclose that I've used AI, even if it's just to write my abstract. I say, I use AI to write my abstract. Or I used AI to generate and format my references. Or I used Grammarly for my grammar checker. You just sort of say upfront, I've used AI in this space. So you want people to sort of self-disclose. And then people use stuff in open scholarly infrastructure like ORCID and DOIs and other pieces to say, yeah, that's a real person. That person exists and they actually did this work.
Yep.
But it's a lot like I remember when I first started dealing with open access and working at the library years ago, someone would say to me, well, if we put this PDF online, how do I make sure no one can print it off? I'm like, I'm sorry, that genie is out of the bottle. Like, there's no way to fix that problem. Like, even at Max, if I couldn't print off the PDF or there was some other obstruction, I can pick up my phone and take a picture of it and OCR it and I've got it. We're in a digital age where it's like almost impossible to lock stuff down. Yeah.
So there are a couple of things that you can do. So one of the things that you can do, especially if it's something that you think is going to be impactful, is to promote it as big as you can, right? And then people know about it. They know it's you. And if they see stuff follow on from it or pulled from it later, that gets flagged much easier, right? It's a little harder it's hard to self-promote. I mean, we're all profs, that's what we do, we're a bunch of narcissists. But
right.
But part of the self-promotion is both to make sure that the articles get out there for the betterment, but also it doubles as in some ways, a safeguard, because we're all scientists. The chemistry community is small. I know hundreds of chemists around the world, and I see their articles all the time. And so when you see something weird or interesting, but you realize that, that we're all friends. So whenever something nefarious, something comes out, someone can say, oh, did you see this? Because that looks like yours or whatever. There is an element of openness in that we see and can navigate. It's hard, but it's a real thing. The other thing, I say philosophy, but the other thing that also dictates whether or not I publish open access is who funded the work, right? So the councils, so NSERC, Natural Science and Engineering Council, fund my work. There's SSHRC, and then there's CHR. And they are part of the Tri-Council who dictate and govern the funding bodies for research in Canada. And they have very specific requirements about how we publish our work. So if it's funded by NSERC, I'm actually obliged to publish it now, open access, in some form, whether it's through Open Access Journal or through a post-print or through the institutional repository. There are different ways to do it, and Mike is the expert, and if you ever have any questions about that, you should talk to him because he helped me navigate it at UNB when I moved here. There are a bunch of different ways to do it and do it safely, and sometimes it's annoying because it's just a lot of extra files, basically, to navigate and deal with, and DOIs and all sorts of shit. But he helped me navigate all of that, and I think if you have any questions, you want to email Mike Nason.
Yeah, please do. It's important, but it's also it is also one more thing, right? It's it's not like you're not busy, and so when you have to go, oh, I need what version of what, and I got to get, and then you send me the thing, and I'm like, no, that wasn't the one, and you're like, God damn it,
I got to do another one.
Yeah, so that, I mean, that happens. It's definitely it's not brainless, and it's not super trivial, but I do think it matters.
As part of our sort of as we start to populate an article, we, at least within my team, we build it into as part of the protocol. So once you've submitted here, we have to send this there and then that there, and then that way it becomes normal for the students to do. And And at that point, that's just what we do. It's normal, and there's no other way around it. So.
Yeah, and you guys have really leaned into, probably they do my favorite thing, which is that they know when they're picking a place to publish what's going to happen. So when you pick a certain publisher, you'll go like, oh, well, they work this way. And you check in advance to know if you're going to get screwed by a surprise fee, because you know in advance whether or not there's fees for that place. That's not normal. Most faculty contact me and go, I put a paper in this place and now they're asking me for money. What happened? And then I have to explain, like, oh, well, you may, if you don't have that, you may have to withdraw your paper and submit somewhere else or whatever. But doing the work in advance is really important.
Yeah, and that actually ties nicely into the next slide. Yeah, believe it or not.
We love a segue. Yes. So, publishing. How did you learn about publishing? How do you decide where to publish? How have your feelings changed over time?
Yeah.
I know your feelings have changed over time. We've had these conversations.
How did you learn about publishing?
That's interesting. Incredibly, I started here at the University of New Brunswick in 2006 on the 5th floor in a space that was then called the Electronic Tech Center. We host journals.
Did you have a dot matrix printer?
Yes. I don't know if it was plugged in, but we did have it. Yeah, no, only the worst in laser jets, for sure. So we publish journals here at UNB. We're library publishing is like almost every academic library in Canada hosts a handful of open access journals that are run by people who are at that institution. There's a really big one in the history department, for example, called Acadiensis that we host. Atlantic Geoscience, a bunch of journals from the region. And my very first job at the library was doing like XML typesetting and markup work and helping with the digital publishing of these journals on the 5th floor. And then I ended up learning a lot about this organization called PKP, the Public Knowledge Project. They make software called Open Journal Systems. I now also work for PKP on the side. And then eventually I did it long enough that I thought, well, I'm doing the work a librarian would do, but I'm getting paid significantly less. I'll just go get the letters and make this official. And that's how I ended up in a publishing space. But it was really funny. I was in a library science program to be sort of a scholarly communications and publishing librarian, and I was the only one who knew anything about it. So like I'm explaining open access to my professors because it wasn't even on their radar when I did it.
That's funny. Yep. So when I was an undergrad, I was doing chemistry in the lab. I was reading the journal articles, and I had no concept. It didn't even occur to me that the names on those articles were students doing that science. And then someone said towards the end, like, oh, this is really good. We could try and publish this. And I was like, it just sort of took me aback. I was like, oh, really? That's kind of weird. And they said, well, no, you've been reading all these people's articles for months. They did it. You can do it. I was like, oh, okay. We published our first article. And then after that, learning how to navigate it was kind of interesting. It was before all of the hyper online submission stuff, so it was a little bit different. Yeah. But yeah, that's sort of where I first kind of got the taste for it. There is no better feeling than getting an email that says your article has been accepted. There's also no worse feeling than when you get an email that says your article has been rejected.
What do you get more of?
Because your science isn't good enough. It's rubbish. Yeah. Yes?
Sometimes I'm thinking that it is my way of thinking. Maybe I'm wrong, okay? But about publication, it is for me, it is like it is bias.
Yeah, totally.
Yeah, absolutely.
They're humans. They are humans. They are humans deciding whether or not they think it's good or not.
Yeah,
it's just completely subjective.
Yeah.
And when you talk about publishing, they will say yes, but you did not publish to this top journal or this one or this one.
Oh yeah, totally.
And sometimes you can publish something. Yeah, we can publish something very deep.
Sure.
And because it's gonna change the way we see the things, you're gonna be we're gonna be rejected.
Yeah, you have to make a compelling argument, right?
Yeah.
It's all in the argument.
Yeah, and you're also fighting hundreds of other people who are also trying to publish in that journal at the same time. Yeah. So it's very competitive, right?
Or profs who are completely overworked and have to review those articles too on the side without pay.
Or editors that are completely overworked and have to review those papers and assign them to reviewers
who
are overworked and do not get paid.
No, it's crazy. Yeah,
it's really good. It's not extractive at all or problematic. Yeah,
it's true.
Yeah.
So, but one of the things that you can do to help ensure that your article gets submitted. There's a bunch of stuff you can do. One of the most important things is to have a really strong cover letter. Just saying, please accept my paper titled this, we hope to hear from you soon, is not acceptable and not good enough. You will get rejected instantly. You need to have a compelling letter, and we won't go into that today. But but the other thing that you can do to sort of give yourself the best chance is that actually, if you think you know where you want to send an article, you should write the article in the sort of flavor that journal typically imbues. So every journal on a whole will have a sort of flavor, or not angle, I would say angle, in the way they write it and what they really want to promote.
Like an editorial style.
Or even like the type of chemistry. So bringing chemistry into as an example, there are some journals who really like crazy conceptual things that were proven and wonderful. And then some journals really like huge amounts of data and proof. And they all require proof, but like some want like exceptional amounts of proof, because that data can then be used for other really interesting things. So the journals themselves all have different flavors in terms of like really where your stuff fits. And so deciding where your stuff fits is really important. You can't just send it to the biggest one every time. Yeah. Right? Because it's going to fit somewhere.
And you have to know.
Yeah, and the hardest part is knowing where to fit. And it might take you a couple of submissions to then see where it kind of fits properly.
Yeah, and to know if your flavor is going to fit the flavor profile.
Yeah.
Of that specific publication.
The mouthfeel?
Yeah, the mouthfeel. But in order to do that, you have to read some issues of it. This is a thing I kind of regularly say to people. They're like, what journals do I publish in? And they just want a list. But they don't read any of those journals. And I always go like, you got to read some of these. Like, you need to spend some time in your discipline reading in the places people publish, so you figure out what's appropriate for your work. Publishing is like you're supposed to put effort in figuring this stuff out if you're putting your best foot forward for where your work goes. Yeah. So I can give you a list of journals whose titles and basic scope notes on their webpage, but I'm not going to go read a bunch of journals for you and tell you if your research, which you know better than me, would fit that thing. Yep. You've got to spend time in your field figuring out, these are the handful of journals I really trust. I know the editorial board. I'm familiar with the people who write in them often, because lots of people have repeat articles. Like, they publish often in a handful of journals. Yep. Not unusual for people to have between 8 and 10 journals they publish in on the regular. And you get a good sense as to what those are, because they fit their community of practice or whatever kind of work they're doing.
For me, like when we get into it, I tend to publish in 2 society journals. There's lots of journals within those publishers that I send to, but there's typically 2 publishers that I send to for various reasons. But the flavor fits my work best, and that's why I send them there. And yes, my feelings of it have changed over time. Mm-hmm. Coming from really big universities where I had an opportunity to have all of the equipment and all of the access to really amazing stuff, I could do really amazing work and then send those articles to really big journals. At UNB, I'm limited in some of the equipment that we require to hit those marks, which means oftentimes we have to argue around certain things, which brings the sort of compellingness of the work down slightly. So oftentimes I find myself submitting to slightly lower journals, but still impactful and important. And it's really then how you publicize your science. There are some articles that are in what some would consider low-level journals that have had the biggest impact in my field.
Right.
And it's because of as I said, the snowball effect over time that brings them there. And there's lots of really big, amazing things that have been done. They're put in Nature and Science, which are the top journals, and they have like 3 citations, which means that even though it's a crazy and an exciting finding, like, okay, then what? Right. And if it brings no extra kind of notoriety or follow-on science, what is that impact really then, right? Being in it might be really cool, but then what? And so being able to translate that becomes important.
Right. Like, you don't just publish in science. You publish in a specific field of chemistry that aligns with the kind of work that you do. You find your niche, right? He's not submitting articles to a place where they're not interested in his findings because the work is completely different than him. He's publishing in a place where the work looks like the kind of work he does, and people understand what it is.
If you actually look at my publication profile, you'll see that I probably publish in a different journal every time. And it's because I'm navigating where I think things should go, where I think they fit right. Maybe I get an invite, but then I really weigh whether or not that is an appropriate place to put it. And sometimes I'll say no thank you. Sometimes I'll say yes, I'll try. And then if we get there and I actually think the science is better than that, I'll decline that and send it somewhere else without hesitation. Right. But it's just about navigating it in an open way. And if you think about, you have to be honest with yourself though too, about where you think your science or your research fits, right?
It means when you
Yeah.
Yeah.
The same
Yeah. Totally. Oh yeah. No, there's not. It doesn't get like a touch of death. No, you can go. You can go. Yeah. Yeah. You don't submit to 10 at a time.
And you get the reviewers' feedback. You can incorporate that.
Yeah.
You can send that off too. Yeah. And then you can make compelling arguments in your cover letter.
Yeah.
You can even, if you think that they are wrong, you can even write a rebuttal letter.
Yeah. Yeah, it's a dialogue. Peer review is a dialogue.
You can fight it. You can fight it. I've fought it, and it's worked out in my favor sometimes. Yeah, it's a real thing. They're people. They're not robots.
Yeah, but this is the other part, right? Rejection is part of the deal because there's such an enormous volume. Like if I accepted everything as an editor that somebody submitted in my journal, I wouldn't be allowed to sleep or do any other thing. Like you have to reject something. Like if you don't do it, then you're either publishing really bad science, for example, because you say, well, we'll treat all things people write the same way. And then you open it up and you go like, well, this is trash, but I said that I would treat this the same way I treat everything else. And now this is my weekend or whatever. But that process takes a really long time. And so you have to be choosy about what you're assigning peer review to, because if you start assigning peer reviewers a bunch of stuff that should never have made it to peer review in the first place, they're not going to want to do peer review for you anymore. And it's already really hard to get people to do peer review. So you have to have this built-in layer of like, is this good enough for me to even want to accept in my journal? And desk rejections are common. Somebody gets desk rejected where the editor just sees it, they don't even assign it. They go like, look, we're not taking papers in this subject at this time for this issue. Maybe it's a special issue coming up or whatever. You go, okay, well, I can rebut, as you say. Well, I think it actually is a good fit. Or you can bench it and do it next year. Or you can find 4 other journals that are on your list and start working your way down through those for submissions and see if they'll take it. But yeah, it's not the end of the road, one single rejection.
The one thing that I tell new academics who are sort of just kind of making their way in is I say that if you can write a compelling cover letter to your submission, you up the chances of getting it out to peer review. Once it's out to peer review, it's a 50-50 chance.
Right.
Because you have people reviewing it. So at that point, it's like the editor doesn't read the article. He reads your letter and maybe the abstract and then decides whether he thinks it's okay or not.
Yeah.
Right? And so really what you want is eyes on the words of the actual writing. And to do that, you need to make a case. And that's where it hits. So, yeah.
I do want to ask a question on here that I think is really important. This idea of student co-authoring.
Yeah.
Can you talk about this a little? Because I don't think this, you mentioned earlier, like learning that students had worked on papers you were reading. And this is disciplinarily very different. Not every discipline does the same thing, but I was wondering if you could talk about it a little bit.
I will, but I want to say first, do you always publish in open access? I try to. Sometimes I have to. Do my opinions differ from my colleagues? Definitely. It's completely personal, as we said. It's oftentimes philosophical.
Yeah.
Unless they're funded by a funder that requires open access, then they have to. So it doesn't matter.
Yeah, but you know what? Sometimes they still don't.
Sometimes they still don't. Yeah. As far as student authoring goes, so it is very much discipline specific. I've been in places where it's been done differently as well. In the sciences, it's often that the student or researcher, I should say, who did all of the work, or most of the work, or the majority of the work would be named as first author, and that the PI who is funding the work would be last author with an asterisk as the corresponding author. And that way, when we're writing it's not just reference letters, but when you're writing a reference letter, the PI can say, this person did all the work, they are first author on this paper, they were the ones who did the majority who drove this science, right? It's a nice way to do that. Some places where you have a lot of researchers, it can be challenging, and quite oftentimes in those instances it goes alphabetical, just to be fair to everybody. And then the cheeky thing is that the PI can then say about anybody in the article when they're writing reference letters to help them advance their careers that, oh, this person, we do alphabetical in our group, but this person was the person who did most of the work, and that could apply to anybody whether they did or not. So it's kind of cheeky, but it's an opportunity to push your students and to help publicize your team as they progress through their careers. Yeah. The other thing is, in some cases, where maybe it's only 2 people who did most of the work, but then there's lots of other people who contributed. And I had to do this recently, actually, as in the acknowledgements at the end of the paper, down by the conclusions and the citations, you can write in there that the first 2 authors are co-first authorship. We've listed them in alphabetical order here, but we give them permission to put their name first on their CVs because they contributed to the project equally. And that's a fair way to ensure that people feel like they're getting their due credit when it's often hard to differentiate. So, but it's completely discipline specific. I would check with your colleagues and your peers with your own discipline in relation to that. But there are nuances that you can play with and navigate to ensure that people get their credit. And that's what it's about, right? Like publishing, there's one thing that we say is publishing in academia, that's our currency. That's the stuff that brings in the money.
Right.
So it's the currency that brings in the currency.
Right. Yeah, and you can always ask too, like if you publish in the humanities, it may be more likely that a PI is the first author, and the other students who contribute might be second or third. It's really cultural, so you just have to ask your advisors when you're publishing or whoever you're working with, what the culture is around co-authorship and what you can expect.
There was one person that was in my group, and they did the work, and it wasn't great, and I had to rework all of it myself, and I got pissed. And when I submitted the paper, I submitted myself as first author with the star in the first author position because I ended up doing almost everything, right? Yeah. And that's fair. That was the credit was to me because I did the work, and I decided that, you know what, for this one time, I'm going to promote myself.
This one time.
Yeah, this one time.
Okay.
But yeah.
Research data. You've been asked to speak about research data at the libraries a couple times. And you use our data repository a whole lot. In fact, I've broken a handful of rules to facilitate you doing functionally whatever you want. And it's worked out really great, actually. What research data do you share, and why do you share it?
Yeah. So I want to tout Mike and his openness to us being able to make use of the repository the way that we do. So research data, this is a new thing, having the open data part of science in Canada. It's now, is it a requirement? Not yet.
No, but knowing where you will put it is a requirement. Having a plan.
They took the data management plan off the recent.
Did they recently?
Grant,
yeah. Having a plan was basically the most recent. Knowing you would do something with it and explaining what you might do with it.
So one of the things that is becoming more and more apparent is that we are generating so much more data than maybe 20 years ago in our science. A lot of that has to do with the fact that we're all using computers now to do it. But we generate a ton of data, and in order for our science to demonstrate its utility, we try to make sure that our data is managed, packaged, and put somewhere that everyone can access. And so the UNB repository, data repository, through what's called the Dataverse, is a place to put our data, so you can package it in a specific file type. We won't get into that. And when you publish it, you get a DOI. And so at the end of the paper, you can write all of our research data that we used here all the underlying that we used to underpin this work can be found here. And we put the DOI. People go to the DOI, and they can access all of our research data. Now, the data that we put there is raw data. Nothing processed, nothing beautiful. If you are a chemist, you know how to process the data because that's our field, and they all know what the file types are and how to navigate that. We delete all of our graphs, all of the images, all of that stuff. That's mine. We make those, right? And that's how we navigate it. You can, if you want to access the data, then you can access the raw data and make the pictures yourself. If you're a chemist, you know how to do that. If you're a biologist, you probably know how to do that. And so what that allows, though, is for the data to be harvested for big data, which people do. And they know how to manage the file types, and so they do that on their own accord. But the data is there if anybody wants to access it, look at it, use it, play with it, and I think that's fair. It's in there, and if you're worried about the paper, then you do it.
Yeah.
Yeah.
Do you use open data at all?
No. I mean, I don't access the data and then do stuff with it. No.
Yeah, right. Okay. Yeah. Okay, we'll move on. Yeah. So, can you tell us a little bit about managing your career, assessment, and how you feel about the phrase research impact? You asked me if this was a loaded question, and it kind of is. But yeah, we talk about this for a minute.
Yeah, the hustle's hard. The one thing that, for me, that kept me going was the inspiration of science, but also my students. I work for my students. They work for me, but I work for them. They want to go and do great things with their career. I'm already in my career, so I owe it to them to try and get them where they want to go, and that's how I sort of approach it. But yeah, I did prepare something for this, and I'm trying to remember what I wrote. Yeah, so it's really about the inspiration of it all, right? Inspired by the science, inspired by innovation. What can we do, right? And how can we then make that impactful?
Right.
That's sort of where that's how I motivate myself anyway.
Yeah,
And I also have to feed my kids.
Right.
That's important.
I suppose that's part of the deal.
Yeah.
If you could give bright-eyed and bushy-tailed grad students advice at this point in their career, what 2 to 3 things would you tell them? And it could be one thing if you want, because we're low on time. What's one good piece of advice that you would give students?
Find something that inspires you.
That's nice.
I said inspired a lot, and that's a lot of it, right?
Right.
And find something that you are into. And
Right.
it may not be something that you're studying right now.
Mm-hmm.
That's okay. Yeah, that's the hardest thing to figure out,
Yeah.
right? When you're young and
Yeah.
yeah.
Yeah, like you're in a program and you actually kind of hate it, and then you take an elective and you're like, hold on a minute, this other thing's incredible.
One extra year in your studies is not going to bother you when you're 65.
Right.
So that's sort of what I tell students.
Right.
If you need to change, then do it.
Yeah.
Yeah.
Is this idiot useful?
Hugely helpful. Yeah. If you have any questions, talk to Mike. He loves going for coffee. He likes going for bike rides. And we've had lots of really useful conversations. As I said, he's given me specific rights in the Dataverse to manage my data myself, which makes things easy and fast and useful. And we also have had lots of really cool conversations about open science and how we can work together. Because oftentimes it's the barriers of the administration of stuff that inhibits what we are supposed to be doing. And Mike's helped lower a lot of those barriers for me, so it's been helpful that way.
Yeah.
I want to be a philosophical scholar. I'm probably a bread-fed scholar. Yeah.
I mean, everybody's a blend.
No, I don't think so.
Everybody's a blend. There's a lot to care about. And then, do you want?
Yeah. So what do we have? Would you like to? Right. So, Mike, tell us how you can help not only just academics, which is me,
Sure.
but grad students. That's important.
I actually think this stuff is really important. The library has these conversations a lot. When I did my master's degree here, I learned virtually nothing about publishing, and I think being curious about the process and learning about what you will do with your research when you graduate is really big. I think it's actually kind of huge. You learn all this stuff as sort of like folk wisdom by asking the one person you trust, who's your advisor, who you have regular conversations with. And that person, just like Barry, has their own preconceptions and understanding of what publishing is, which may or may not match your own.
And it's completely biased.
Totally.
Yeah.
Totally biased. So ask a bunch of other people and learn more about publishing and be curious about it. Because honestly, you spend all of this time learning how to do research, and then you graduate and go on and do other jobs. And the part you get evaluated on is the publishing part, where you've put your work. Can people read your work? Where can they read your work? Access to that stuff. It's hugely, hugely important. And it's really, really easy to overlook. So, I can help you by you showing up to these things and being engaged. You pay attention to those things. And anytime you have a question, you can hit me up. I'm even happy you can DM me on Teams. You don't have to send me an email. I will not answer my phone under any circumstances. Do not try. But like Amin, you can absolutely just flag me down in the middle of the place. And as long as I have more than 5 minutes to talk to you, I will stop and have a chat. Anytime. I'm always happy to help and to walk people through stuff. It's literally my job is to help people. So.
And I want to say the data management part doesn't need to be Dataverse stuff.
No.
Like it can be using SharePoint effectively.
I hate SharePoint.
I know it's the worst, but it's also really useful. And so our team now has a comprehensive way of working through SharePoint to make sure our data doesn't get lost.
Right.
Yeah.
I'm always happy to help even if I don't know the answer to the question because I have no boundaries.
I actually have a quick question on the data part. I noticed you could include data in your publication, or you could have it, I guess, separately. But I think a lot of journals don't have that separate thing where you would put it in the big database.
Well, you can make your own and then have a link to it. They can't leave. You can put the, like I said, we put the DOI right in the acknowledgements, basically.
Yeah, and in Dataverse too, it's very common. You can actually submit your content to Dataverse and upload it to the repository, but without publishing. You can generate a URL for the journal to access the data before you've even published it. And then when the work's published, you can decide to publish the data set after the fact with the DOI for the article included. Yeah. So all of that stuff is circular. So those data repositories are meant to work inside of a workflow that journals typically use. And you don't have to publish in advance or any of that stuff.
One of the nice things too with peer review, if you include the link before you send it for peer review, if you include it in the body, the reviewers can go look at the raw data if they want to. Right, which means you're showing openness in your approach to the science straight away.
Yeah.
I was thinking in particular because the field that I was contemplating is kind of a hybrid field and a new field. So like in the mature sciences, like if you're talking chemistry, physics, whatever, they already have that all figured out in the publication process. But in like, for example, what I'm doing is geometrics. That's really vexed. And like the data something you want to open source, or the data is something you want to make private? Or so like, are there tools to address that? You mentioned like hyperlinking. That's pretty interesting.
Yeah, you can link out for an individual, but the other part is like, you're not obligated to make open source the data you put in a repository. You can restrict whatever you want. Mm-hmm. So when you're uploading something to Dataverse, you can go, well, okay, we're going to put all this stuff here now. I'm going to lock it, but I've got it somewhere in a nice big, place that's going to be preserved or taken care of. And then later I'm going to open it once I decide what's up. There's lots of data that people do, like they hear research data and digitization and research data management. They think, well, I do research with sensitive populations and I can't put that online. We're not asking you to. Like there are rules about sensitive data and where you put it that we would never ask somebody to violate in order to put their data in a place. We're basically saying we have a service to store this volume of data that is not a zip drive you will forget you own, or a little USB card or some other dumb thing. Like we'll put this in a place that is secure and taken care of, and you decide who sees it. Any individual file you can lock down. You can say this is public, this isn't, or the whole thing can be private.
I think you can put dates on it too. If you want to embargo it.
Yeah, embargo dates.
It'll automatically go live 12 months later.
Yeah, so you're in control of the distribution for any of the data you share, and it doesn't have to be open. And I can't imagine a scenario where there is an open data mandate from the government, because people would flip out. There's a lot of stuff you're not allowed to share in research data. So, I think it's approach it knowing that those safeguards are there. But the RDM page on the library website has a lot of like considerations for how to share your data. There's stuff about sensitive data and other pieces. So just go to the library site and look for research data management, and there's a ton of resources there on what you might want to consider.
That's awesome, including your email and contact. I guess it comes with I'd say you've answered a very useful question.
I think we're time. Hey.
Yes, we're 4 on the dot.
4 on the dot.
Hey, we did it.
We did it.
Yes.
Success.
Thank you.